Hi all. Today I am going to discuss about the another topic in computer network, that is network models. Actually, these network models are used to give some set of rules and regulation for network communication. There are basically two models in computer networks, OSI model and TCP/IP model. The TCP/IP model is the exact working model in the computer network, but OSI model is the basic model in the network. So, in this class, I am just giving the idea about OSI model, and this OSI model stands for Open System Interconnection. It is a reference model that specifies standards for communication protocols and also the functionalities of each layer. Actually, this OSI model is the function oriented approach. That is, in TCP/IP model is the real computer network model, but here the OSI model is just representing the functionality of each layer. This is developed by International Organization for Standardization, and it has mainly several layers. Those are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The, this is the pictorial representation of OSI model. In this, we can see that the data units on the left side. That data unit means how the data is transmitted over through these seven layers. The base level is the physical layer. Here the data unit is in the form of bits. The next level it is converted into frames. The network layer it is the data unit is packets, then segments, and the above transport layer. All other layers consider this data unit as message or data. And next, here in this class, I am only explaining about the physical layer in the OSI model and its functionality. The physical layer is the lowest layer in the 7-layer OSI model. It is responsible for sending raw data as electrical signals, light pulses, or radio waves over a physical medium like cables or wireless channels. And various hardware components such as cables, switches, network interface card, are the hardware components used in this physical layer. It plays an important role in establishing and maintaining actual connection between the devices in a network. And this physical layer sends data bits from one devices to another. This main functionality of the physical layer is the data sends from one devices to another devices in the form of bits. And the services offered by a physical layer are: the first one is bit by bit data transmission. The physical layer transmits data in the form of individual bits. It does not organize these bits into a group such as packets or frames. Instead, it simply ensures that bits are sent from sender to the receiver over a medium, either guided media such as coaxial cable, fiber cable, or unguided media such as electromagnetic waves, radio waves, infrared waves, microwaves, like that. We are simply sending the data. That is one main function of physical layer. Next is the types of transmission media. You, we already mentioned that guided media and unguided media. These are all the examples of guided media. That is, guided media is again classified into coaxial cable, twisted pair cable, fiber optics. And coaxial cable examples are RG59, RG58, RG11. Twisted pair cable examples are UTP, STP. Fiber optics cables are examples. For that, single mode fiber optics cables are available, multi mode cables are available. Unguided media, we all know the unguided media is infrared waves, radio waves, microwaves. The next function of physical layer is the encoding and decoding. Encoding converts the digital data, that is zeros and ones, into a signal suitable for transmission. The receiving device then decodes these signals back into the digital data. This process ensures that the signals can travel efficiently and be correctly interpreted at the destination. The next is the types of encoding schemes. The non-return to zero and Manchester encodings are the two types of encoding schemes mainly used. And in NR set, in this type of encoding, we are directly represent zeros and one using different voltage level. Manchester encoding uses transition in the signal indicate bits, making it more reliable. Next is signal transmission is another function of physical layer. In this signal transmission, how the signals are traveled through a medium, and the physical layer is responsible for how the signals travel through a medium, and it can be transmitted in two primary forms: digital signals and analog signals. This digital signal is that represent data using discrete values, that is zeros and ones. That nowadays we are mostly using digital signals. Analog signal is the traditional way of representing representing the data transmission. It is a continuous wave that varies over time. It represents information using changes in amplitude, frequency, or phase. Next is, since modern networks use digital signals, but some traditional systems still using analog signals. Hence, these signals are often converted to each other, so that analog to digital conversion is needed and also digital to analog conversion is needed. That ADC convert analog signals into digital signal for computer processing. DAC convert digital signal into analog signal transmission over traditional analog systems. Modulation and demodulation. Modulation is the process of converting digital data into a form that can travel efficiently over a medium, especially in wireless and analog system. That is modulation mainly used in wireless and analog systems. Demodulation is the reverse process or the opposite of modulation. That is, in this demodulation, the data is extracted from the transmitted signal. The modulation techniques are amplitude modulation, frequency modulation, phase modulation, and these are all the functions we discuss. And next is transmission modes. Transmission mode is the physical layer defines how data flows between devices. That is, we can send data through this transmission mode. There are mainly three transmission modes: simplex, half duplex, and full duplex. In simplex mode, data flows in one direction. The sender can transmit data, but the receiver cannot send back information. For example, a TV broadcast where the station sends signals but does not receive any data from the TV. In half duplex mode, data flows in both directions but only one direction at a time. The sender must wait until the receiver finishes before responding. Examples: walkie-talkies, where users must take turns speaking. In half duplex mode, we should remember that we can communicate with each other but only one direction at a time. Here, the word you should remember: one direction at a time, only one direction is possible. But in full duplex mode, data flows in both directions simultaneously. It increases communication speed by allowing continuous data exchange. We can communicate continuously. In this full duplex mode, we can communicate continuously without any wait, or there is no wait in between sender and receiver. The examples is telephone conversation where both people can talk and listen at the same time. And this is the pictorial representation of the transmission mode, that is simplex, half duplex, full duplex. Here the sender can send data only in one direction. Half duplex mode, both can send data but one in at a time. Cannot send both together. Full duplex mode, sender can also send, the receiver also can send the data simultaneously. Next is data control. The physical layer helps manage the timing and flow of data to prevent errors and inefficiencies in transmission. That is, data control means the physical layer is responsible for giving timing and flow and the preventing the error in the data transmission. For that, it is implementing synchronization and flow control mechanism. Synchronization means the sender and the receiver are in a sync so that the bits are interpreted correctly. There should be synchronization mechanism if between the sender and the receiver, then only the data communication is uh, accurate and efficiently we can communicate. The flow control manages the speed difference between sender and the receiver to ensure smooth communication. The speed difference, this is mandatory that if a sender is sending one data, the receiver should receive that data in a particular time. Otherwise, if it will the sender receiving data is not received by the receiver, there will be some loss of data and a communication error will happen. So there should be some flow control also. These are all the responsibilities of physical layer. But in some of the limitations of physical layer services are signal degrade over long distance and it require repeaters or amplifiers. If we are sending data to a long distance, there should be a chance that signal will be degradable. So we need to use repeaters or amplifiers for regenerating the signal or amplifying the signal. Next is electrical and radio noise can cause data corruption. There is a chance for the data corruption due to the radio noise or electrical noise. And the physical layer does not check for transmission error. This is one of the disadvantages of physical layer, that it does not check for transmission errors. Error handling is done in higher layers such as data link layer. The physical layer, we told that this is the bottom level in the OSI model, so it does not check transmission error. In the above layers in the OSI model will do this error handling function. And speed of data transmission depends on the physical medium and available bandwidth. Another limitation of physical layer is services is that speed of data transmission, it is depending on the physical media, what type of media we are using, and that media have how much bandwidth it has. These are the factors affecting the data transmission speed. In this class, we have learned the functionalities of physical layer. Those are bit by bit transmission, encoding and decoding, signal transmission, modulation and demodulation, transmission modes, data control. Thank you.